Welcome back to Maths with Mrs. J. We're now ready to learn how to integrate our trig functions. As with all our other examples of integration, I've referred back to the derivatives because remember, integration and differentiation are basically the opposite thing. The only difference might be that you might have a different constant term coming in there. If you're differentiating sine of x with respect to x, you get cos of x. Therefore, the integral of cos is sine plus your constant term. This negative has shifted here, so I'm just going to move it back. If you are differentiating cos of x, you get negative sine of x. So if you're integrating sine of x, we're going to get negative cos of x. If we're differentiating tan of x with respect to x, we get sec squared of x, which is 1 over cos squared x. So if we're integrating sec squared, of course, we get tan of x plus c. Let's go through some examples. We're going to draw upon a few bits of knowledge here, including our unit circle knowledge, our identity knowledge. Everything starts to sort of come together once you're in year 11 and 12, so you can't really afford to compartmentalise certain topics and say, oh, well, that was that topic, I don't need to know that anymore. All right, let's have a look at the first one. Integral of cos of 2x. Okay, well, it's going to be sine of 2x, but using our chain rule in reverse, if you were to differentiate sine of 2x, you'd get sine of 2x, but you'd have to multiply by 2, wouldn't you? We don't have the 2, so we're going to divide by it here to make it work. There are two ways we can look at our second question. We could say, okay, well, it's negative a third cos of this. The reason we need our third is because of our 3x. But a better way to look at it would be this. Notice that this is a pi on 2 plus theta situation. Thinking back to our unit circle and our vertical reference business, sine of pi on 2 plus theta is just cos of theta. So I would be inclined to actually say this equals cos of 3x dx and just get our 1/3 sine of 3x plus c. You could even change it at this stage. Cos of pi on 2 plus theta is negative sine, so the negatives would cancel out and you'd end up with the same answer. Having a look at this one here, by now I would hope that you would recognise sine squared plus cos squared is 1. This is just the integral of 1, which is just x plus your c. Do not forget that Pythagorean identity, very important. Because you can't yet, you haven't learned how to integrate sine squared or cos squared. All right, we know that the integral of sec of x is tan of x, sec squared of x, is tan of x. So we've got sec squared of 5x, so we need to divide by 5 to make it work. Chain rule in reverse. Well, we'll be doing some videos soon where we, I guess, formalise that chain rule in reverse business. It's technically called integration by substitution. I find recognising chain rule in reverse is actually easier. This one here, again, we've got another chain rule in reverse situation. This here is a composite function. We've got sine of x squared plus 1. The derivative of x squared plus 1 is 2x. So by using our chain rule in reverse, this is going to be the same as negative cos of x squared plus 1 plus our c. Because if I were to differentiate this, I'm going to go back and get positive sine, and then I'm going to multiply by the derivative of that inner function, which will be 2x. So that's how that basically works there using your chain rule in reverse. Doesn't really matter whether you're talking about trig functions, polynomials, exponentials, whatever it is. If you happen to have a scenario where you have a composite function and you've got a multiplication by the derivative of that or some constant times the derivative of that, you're good to go as far as chain rule in reverse is concerned.